Okay, so having some technical difficulties with the slides and the resolution, so everyone just bear with me here. But thankfully, I know the slides by heart, so it shouldn't be that much of a problem. So hope you're all having a good DerbyCon so far. Let me just do this. So there was going to be a dope logo there, but as you can see, there's nothing now. But we're going to be talking about Active Directory. We're going to be talking about a tool that I wrote called CrackMapExec, and that I've been maintaining for the past year or so now. And just two things before I start out. One, this is my second time talking to a fairly large audience, so if I do anything weird or just act awkwardly, just go with it. Second, the main theme, we're going to be talking about Active Directory from a fairly offensive side. This is going to be a fairly demo-heavy talk. Hopefully the demos won't fail. Demo gods be with me. And we are also, the theme that I want to convey here is what you would be seeing underneath the title of the slide here, which is Owning Active Directory Using Active Directory. So if you've been in the pen testing space for a little while now, you probably have heard of the term living off the land, right? So basically using built-in Microsoft tools, feature sets, protocols, and using them against themselves for pen testing purposes and post-exploitation purposes. And this is really the main theme that CME was built upon. It's been built upon completely around this main theme. So everything what I'm about to show you, again, if the demos don't fail, is doing exactly that. There is nothing that's going to be done that's out of the ordinary in an Active Directory environment. And this is where I would show you the obligatory Who Am I slide. But so I work for Coalfire Labs, and my handle's BipeLeader. If you've seen some of the projects that I've been working on, I'm a pretty open source guy. I've been working on a number of projects. Hopefully you can see that. That is my GitHub profile. That is my PGP key on Keybase, just in case you want to send me something and encrypt all the things. So what is this thing and up with the name? This is an AD pen testing tool. This should be helping you during your internal assessments. It should be helping you saving a lot of time when pen testing Active Directory environments. You're probably wondering, okay, why do we need yet another one of these tools? I will explain that in a second. The name is really awkward. This is awesome. Okay. So basically CME was based off of these three tools, which again, really hard to see. But anyway, CredCrack, SMBmap, and SMBexec. So these three tools are what CME was based off of. CredCrack, if you're familiar with it at all, it basically automated executing Mimikatz on huge environments. There was some implementation issues with that and some configurations issues with that. And this is what inspired the CME's main Mimikatz functionality. SMBmap is another tool that came out fairly recently. I actually had the pleasure of meeting Sean at Black Hat for the first time. And fun fact was that CME actually started out as a pull request to the SMBmap project. And I just started hacking on the code, and at the end of a rage code session, I just had something that was just completely different than the SMBmap project. So I decided to start my own little project. And then SMBexec. SMBexec is pretty much that's much better actually. Hope everyone was hearing me. SMBexec is and still is probably the go-to tool when it comes to AD pen testing. Although it does stuff that I like to call it the pre-PowerShell era way of doing things, such as uploading binaries to disk. It uses Windows Credential Editor, which I'm not even sure if anyone uses that anymore. It does a lot of stuff that we don't need to do anymore because PowerShell and its black voodoo magic that enables us to inject arbitrary binaries into memory and a whole other sleuth of things that We can do a lot more stealthily. And as pen testers, we should be striving to do that, to emulate real attacks, and to give more value to customers. So, the title here says I have 99 or 8 problems, just FYI. So these 8 problems features that I wanted in a AD tool was large networks. So how many times have you just been dumped on a large network as a pen tester, and the client goes, okay, you have to now test this 100,000 host network, but you only have a week to do it. And good luck with that. Like that's something that, you know, it's going to be fun, but it's going to take a lot more time than a week, at least for me, right? And so I wanted something fast. I needed something preferably with concurrency, which is not something that previous tools have done well, especially Python tools. The built-in threading module in Python isn't actually concurrency, and this is a point of confusion for a lot of people. That's concurrent multitasking, which is a completely different thing. Concurrency is actually doing multiple things at the same time, while concurrent multitasking is doing the same thing across multiple threads. So it's a very different aspect that it's a point of confusion, and CME kind of solves that by using a third-party library called gevent in Python, which is probably the closest thing that you'll ever get to concurrency when it comes to Python, at least from what I understand. And Python 2.7, that is. The second point of this, it's kind of useless showing the slides at this point, but credential overload. So if you've ever been on a large network, the amount of credentials that you get once you establish your initial foothold just increases exponentially from one host to another. I'm not a statistician or a mathematician, and in fact I suck at both of those things. But if you actually did the graph, I bet it would be a quasi-exponential curve. And I needed something that would help me with that, right? So I needed something to easily correlate specific credentials to specific resources and vice versa, so that I can easily and quickly just figure out which credentials I needed to access a specific resource. The third one is situational awareness. So PowerView. How many of you have heard of PowerView? I bet pretty much everyone, I guess. So I wanted to integrate a lot of the PowerView functionality, and I've actually done that by writing a module system with the module system, which we'll get into later. Actually, I forgot what the fourth one is, but judging by the TION, okay, well, we'll skip that. And the fifth one is stealth and living off the land, which is basically the main theme that CME was built upon. And the sixth one is external tools. If you're familiar with SMBExec in any way, you should be aware that SMBExec actually uses the passing the hash toolkit in the backend to perform all of its stuff. And if you're using a custom pentest OS, which I know a lot of you do, I do in particular, I don't use Kali, it's such a pain in the ass to compile those tools, it's not even funny. And actually, I have not gotten them to compile from source even once. So I didn't want anything with external tools. I wanted something that was just pure Python. And I wanted it to be the glue between Metasploit and Empire. So what I mean by that is easily lobbing shells between both frameworks and sharing credentials between both frameworks. On internal assessments, I usually use a combination of both frameworks just because the pros of one, they both have pros and cons, and using both kind of outweighs those feature sets. So I wanted something to easily lob shells between frameworks and share credentials between frameworks. And the sixth one, I forget, so we will just skip that. So thankfully, because a lot of people and a lot of time was invested in other libraries and projects, I didn't have to start from scratch. So I'm just a guy that just came along and sort of put the pieces together. Thankfully, I did not have to start from scratch at all. And these are the projects that in theory help me. Well, anyway, okay, so InPacket. InPacket, if you should be using InPacket on every internal assessment. If you're not, you're doing it wrong in my opinion. Alberto Solino, which is the guy that develops it, is pretty much a god in my eyes. Like, I have no clue how he does it. InPacket, if you're not familiar with it, it's a library, and it comes with a lot of example scripts that just helps so much during internal pen tests, and it kind of abstracts a lot of the low-level protocols that Active Directory uses. The second one is PowerSploit, which I'm pretty sure that everyone's familiar with PowerSploit. So I wanted a way of integrating the PowerSploit framework inside of this tool. And the third one is Mimikatz, which, again, I don't need to explain Mimikatz. It's pretty much, it should be used on every internal assessment. So, this is a heavy demo talk. Demo gods in the past have been really bad to me, so hopefully these will work this time. But we're going to be simulating a mock pen test. And usually getting an initial foothold on a Windows Active Directory network isn't that hard at all. My preference is using SMB relaying, which is another point of confusion. The credentials that you get with Responder, those you don't need to actually crack those hashes. You can just relay them. And this is something I don't think a lot of people know. Net NTLM v2, you are able to relay those hashes without cracking them. And you can do this by really quickly, because could be a whole nother talk on its own. You can do this by turning off the SMB, HTTP, and HTTPS server that Responder has in its configuration file, and then using a relaying tool. My preference is NTLM relay.x.py, which is a example script that comes with the InPacket library. And you can use that in combination with Responder to just pop shells from every credential that you relay. And it's awesome. But for the live demo, which we will get to now. For the live demo, the company that we're going to attack, we're just going to pretend that it's got everything locked down. Like, it has SMB signing enabled, so you can't relay hashes. It has it doesn't have any multicast broadcast protocols enabled, so you can't use Responder. You've tried like password spraying or whatnot, doesn't work. And it has everything patched. So they got shit locked down, and you can't get an initial foothold. But let's pretend that you did some OSINT just externally, and you found a couple of Active Directory usernames on the web, right? So my first approach in that case would be password spraying. So we're just going to do that. So once you install CME, which if you go to the project page, there's the installation guide right there. You're able to invoke it using the CME command. Does everyone see that, by the way? Do I need to increase the font? Yes? It's good? Oh, bigger font. Okay, cool. Let me just do that real quick. Let's go all the way to 25. Okay, does that help? Is that better? Okay, everyone see? Cool. Okay, so you invoke the actual program either by using CME or the full name, CrackMapExec, which is awkward as hell, I know. I kind of like the awkwardness, to be frank. And the first thing that I do is just scan the subnet that I'm attacking, right? So I invoke CME and I give it the subnet of the network. Okay. So the font is big and the resolution sucks, so just go with it. So the output gives you the IP of the host and the host name. And since you can actually get OS, domain, and hostname information without any credentials whatsoever, it shows you that on the rest of the line. So you can see here that we have 3 machines in this domain. The domain is called lab. Excuse me. We have a Windows 6.3 box, which is Windows 2012. We have a Windows 6.1 box, which is Windows 7. and a Windows 10 box, which is Windows 10, and the host names are named appropriately. So let's say that in this mock pen test, you found Bob, right? Bob is the username, and we want to get an initial full load, so we'll try password spraying. So CME out of the box supports that by just passing multiple username and passwords as command line arguments. With the -u and -p flag, you specify the username and password respectively. You can also specify a file containing those username and passwords, but just for convenience sake, we're just going to specify it on the command line. So Bob, and we give it password1, and I don't know, change me, and password1, 2, 3. So, again, resolution sucks. I apologize for that. But you can see here that the CME automatically brute forced the credentials, brute forced the credentials which you provided. So it tried logging in with password1, change me, and password1, 2, 3, and we see we have a successful authentication with password1, 2, 3. So Bob apparently sucks at creating passwords. And we're able to authenticate to all the machines. This is a valid domain account, so we're able to authenticate to the domain. The problem is, Bob is just a regular old user. He doesn't have admin access. So we can't really do much at this point. And one thing that I want to underline is that CME is very much a post-exploitation tool, so you can't really do much with it without a set of credentials in the first place. So we know that Bob's password is password1, 2, 3. And we're just going to target one, well, actually, we're just going to target the whole subnet at this point. And we're going to pass it the --shares argument, which is going to enumerate all of the available shares on all of the hosts that we can authenticate to. And so, on the Windows 10 box, we have 3 available shares. We have the C, admin, IPC, usual, and they all seem usual. And the thing that you'll notice here is that CME actually tells you the permissions that you have on those shares. So it's a really quick and easy way of identifying what you can access this way. So see that we have no access to the admin share here. We have read access to IPC, which won't give us nothing. And everything is kind of standard except for the Windows 7 box, which has a share called all the stuff, and we have read access to it. So Bob has read access to this share on this machine. So let's take advantage of that, right? So CME has built-in spidering support, so we can spider both the files on that share, but we can also spider the content of those files on that share. And this is really handy when you have like multiple Word docs on a share and you want to be able to spider. Word docs are essentially zip files with XML in them, and CME is able to actually parse those and like search for a specific pattern or regex. So I'm just going to specify the password, and with the --spider option, we tell it to start spidering. Sorry. Oh. Perfect. And we're just going to tell it to share, and I think that was 192. I think it was 12. So we're not going to spider every host on the subnet. We just want to spider one. You can actually do that, by the way. If you wanted to spider every host on a subnet, you can do that with CME because it's almost truly concurrent. Let me specify the share. So all the stuff and a pattern. So I'm just going to look for pass here, and hopefully it doesn't look that bad from what you're seeing, but you can see that we successfully authenticated to the share over here using those specified credentials. We started spidering, and we found one file on the share called password.txt. Now, we can pull down that file, but again, just for interest of time, because we have a lot of content to go through, that text file doesn't actually contain credentials. It's just a random text file without credentials. So this time, I'm going to actually spider the contents of the files on that share and see if we have any hits. And you can see we have a second hit this time. And password.txt always shows up because it does, in this case, it does spider the file name, it does search for the pattern in the file name and in the contents. So in the first hit, we have password.txt, which was before, and in the second hit, we have cooking.txt, which, as you can see, the file name makes no sense whatsoever. If you actually went to open that up, it does have credentials in it, and specifically, you can see here that the output shows you. So at offset 75, we have that match for the pattern password. And in this case, that file, again, in the interest of time, I would usually pull it down, but that file has credentials for the user Tom. So we have another set of credentials at this point that we can use and test against the Active Directory network that we are pen testing. So Tom, and just going forward, I put this in here because it's just, I have a very weird sense of humor. So these are actually passwords that I found on gigs, just during internal assessments. So Tom here has the password that's 69 pickles. And we're going to try that. We're going to authenticate to the whole subnet using those credentials. So it's a valid credential set. You can see here that we authenticated successfully to all the 3 machines. But if you notice here, on the Windows 10 machine, we have this little pwned flag that gets appended to the authentication. And what that means is that this credential set has admin access over that host. So this is a really quick way of determining which credential set, the credentials that you just pillage from whichever method you want, which has admin access over that host. And this is where the real fun begins with CME, because once you have admin access over that host, you can use the module system and you can execute commands. So we have admin access over the Windows 10 box, which is at 11, if I recall correctly. Yes, it's at 11. So before we do anything really noisy, let's just do some really quick recon and see what can we get from the box at .11. So what I like doing is first, we had already enumerated the shares. So we can try enumerating logged on users. And you can see that there aren't any logged on users, which is normal because my VMs crapped out on me. So let's just open that up real quick. And Windows 10. So we're performing an interactive logon here, so you actually see that it's enumerating logged on users. And again, all of this is using all of this is being performed using Win32 API calls. So if you actually went to analyze all of this traffic, you wouldn't see anything out of the ordinary but domain traffic. So Tom is now logged on, and we enumerate logged on users, and you can see that this time Tom was over there. Hopefully that's not that bad. But Tom is logged on to that machine. We can also see if there are any sessions. There aren't any sessions, so no active sessions on that machine. But what we can do is we can use a payload module. So CME implements a concept called payload modules, which are basically just PowerShell payloads that are custom made to do certain things on hosts that you have admin access to. So in this case, I'm going to use the PowerView payload module, and I apologize again, but PowerView payload module, which is basically just a wrapper for all of the PowerView functions. And what this does, so first of all, let's execute the module. So I'm specifying with the capital -M flag, the module I want to run. And what this does, really quickly, is it hosts the PowerView.ps1 PowerShell script locally over HTTPS. It then executes a PowerShell IEX cradle, invoke expression cradle, to download that PowerShell script in memory, and then executes whichever command that we specify. So in this case, we're going to specify get net group member. If I recall correctly, that's the correct PowerView function. Oh, yes, that's correct. Thank you. So we're going to specify that. So what this is going to do, it's going to go out, it's going to execute a PowerShell one-liner over WMI, and then it's going to pull down the PowerShell script over HTTPS, and it's going to execute that command that we specified. So you can see here that we got a callback. So the host successfully pulled down the PowerShell script, and it posted back, again, over HTTPS, so this is a completely encrypted channel. It posted back the result of that PowerView command, and you can see here that the group name is domain admins. So we enumerated successfully all of the domain admins in the environment using PowerView. And we have two members of the domain admins group. We have Alice, you can see here, and the just standard administrator domain admin account. So we have some situational awareness already. We can also just directly execute without using the payload module system. We can just directly execute commands since we have admin access to this host. So say we wanted to execute ipconfig. Using the -x flag, we can just execute standard commands. And all of this is being performed completely fileless. So the default method of execution for CME, it supports is WMI. It does support other methods of execution, which are similar to PSExec and ATExec, which ATExec is basically a way of executing commands through Windows Task Scheduler. But the standard method of execution of CME is WMI. So you can see here that we successfully executed the ipconfig command, and this is the output for that host. So let's say we wanted to do something now a little bit more noisy. CME comes with a Mimikatz module, and it does exactly what it sounds like. So it just basically downloads Mimikatz in memory and executes it and posts back the output via HTTPS. So you can see here that it's kind of the way the HTTPS server is implemented. It's kind of smart. It won't exit out until all of the hosts that it executed a command on will post back their output. So we've successfully executed Mimikatz on this host, and we have 3 hits. And I have I'm really confused why it gave us credentials here, because it's a Windows 10 box and it shouldn't have given us clear text credentials, but okay, I'll just go with it. And so we have a hash for user Tom, and we have the password for user Tom, as expected. I'm just going to skip ahead here, but just to show you how fast this is, it's not recommended, but I have once or twice Mimikatz the /24. And it's noisy, but it's actually pretty fast. So if I wanted to execute Mimikatz, I'm just going to use the domain admin password here. And again, this is another real password that I found. So Gandalf kicks ass and licks butt. Yep. And I'm going to use this creative password on the /24. I'm just going to execute Mimikatz on all 3 boxes at the same time. And I messed something up. Wonderful. So let's try that again. Gandalf kicks. Oh, yes. There you go. Thank you, sir. Yes, that worked. Thanks. Okay, well, it worked on, yeah, it worked. So we've executed a Mimikatz on all 3 hosts, so we got 2 callbacks so far. And this is the credentials for the Windows 10 box, and this is the credentials for the Windows 7 box. And we should also be getting credentials from the domain controller. Yes, there they are. So we've executed Mimikatz on 3 hosts at the same time in under, what, that was like 10 seconds. So we have, going back to the pen test, mock pen test, we have admin access to the Windows 10 box. We want to try to move laterally now at this point. So the most common misconfiguration that I find on domain networks are local administrator passwords that are the same between multiple computers. And either those were pushed out via group policy or whatever. That is the most common misconfiguration that I find. And I'm just going to use Tom again. And I'm going to specify the --SAM flag. And this does what you think it does. It just dumps the local SAM database from the machine. Nope, that was the wrong one. Okay, so you can see here that we've successfully dumped the SAM hashes from the Windows 10 machine. And this is the administrator, the local administrator's password hash, right? And let's see if I can, yeah, okay, that should work. So now, since I've dumped the SAM hashes from the Windows 10 machine, I'm going to try and authenticate locally with that administrator password hash to the rest of the machines to see if that misconfiguration in that environment is actually the case. So username administrator, and we're gonna, with the capital H flag, we specify the local administrator hash, in theory. Yes, there it is. So that's just the NTLM hash of that account. And I'm gonna pass it the --local flag, which will tell it to authenticate locally to every machine instead of domain-wide, and see what happens. And we have, oh, yes, that's correct. Oh yeah, and this we don't need, which is why it errored out. Okay, let's try that again. So, you can see with this account, we have now admin access to another host. Before we had admin access to only Windows 10, the Windows 10 machine. Now we have admin access to the Windows 7 machine because they configured the local administrator accounts with the same password between multiple machines. So now we can execute payload modules on that machine too. So if I wanted to execute Mimikatz on the Windows 7 machine, let me just log into that real quick because this stopped working. Delete. Okay, cool. So I'm logged in now. And I can now use the this local administrator password hash to execute Mimikatz again. And that didn't work because I didn't specify --local. Okay. So you can see we successfully passed the hash. We authenticated locally to both of those machines, and we have credentials now on both of those machines. So you can see here the password for Alice. Now again, I'm showing you this on 3 VMs because I have a laptop and for demo purposes this is fine, but you could actually do this on a /24 or even a /16, although not recommended, and it would probably be pretty fast. By default, CME spins up 100 concurrent threads. You can specify more threads if you want to do a /16 with the -T option. So you can specify maybe like even like 200 or 500 concurrent threads if you wanted to. But yeah, it is pretty fast. And this is, now I want to tell you a little bit about the database. So everything that we've done so far now has been passively logged to the database. And CME ships with a command line program called CMEDB, and I am running extremely late. So CMEDB is just a CLI interface to the backend database of CME. And if you're all familiar with Empire or Metasploit, you should feel at home here. With credentials, with the creds command, it just shows you all the credentials that you've used so far. And going back to the the 8 features that I've always wanted to see in one of these tools, this pretty much does it. So you can see here that it automatically logs all the credentials that you use. So Alice, the domain administrator password, the domain administrator account that we had used before, has admin access on 3 hosts. So it automatically tells you, it automatically logs the admin access of each account. So Tom here has admin access over 1 host, and so on and so forth. And if you specify the actual account with the creds command, it shows you which host is that it has admin access on. So Alice here, no, wrong one. So Alice here has admin access to these 3 machines. So this is, if you've done AD pen testing in the past, this should be a hell of a time saver, just because it allows you to quickly correlate the credential set to the specific resource that it has admin access to, and vice versa. And every host that CME touches is also logged as well to perform this correlation. So if we ran the host command, these are all the machines that we've touched so far. So the domain controller, Windows 10 box, and Windows 7 box, and it shows you that, okay, the domain controller has 1 credentials with admin access to it, and so on and so forth. And this is a new feature, actually, which I've just implemented. So if you run the Mimikatz payload module on machines, it actually shows you from what machine you pillaged that credential from. So here, apologize for the resolution again, you can see that the host ID from which this credential was taken from is number 3. So if I wanted to find out which host is number 3, I just do host 3. And you can see that that was taken from the Windows 7 box. So again, for reporting purposes and just for long-term engagements, this should be a time saver. So CME comes with a bunch of modules, which, because I'm running so late on time, I will show you just really quickly. And this font is really small, but we're just going to go with it. Really quickly, that you can actually get shells on a /24, either using Empire or Metasploit using CME. So if we use the domain admin password again, 168.122.0/24, and specify, let me just see if I have this in my, yes, cool, okay. So, the met inject module, and this does what it sounds like. So it directly injects Meterpreter into memory using PowerShell. And we specify the module using the -m flag, and we specify the L host using the -o flag. So it accepts, each module can accept arguments, and you can specify them using the key value style, like MSF Venom, if you're familiar with it. So the L host would be 192.168.122.1, and the L port would be 8443. Okay, that should all work. Over here, I don't want to restart the Metasploit instance, but we have a reverse HTTPS handler set up, and we have no sessions currently active. And I don't know how to type apparently. 1, 2, 3. Okay. So we successfully executed the initial payload launcher on all 3 machines. And this is going to call back and download the invoke shellcode.ps1 script, which is part of the PowerSploit framework. And if we go back here, we see we already are getting shells. And we use the second shell from the domain controller and the first shell from the Windows 7 machine. And just to show you that I'm not lying, get UID. Yes, and that's the third shell coming in right now. So if you wanted to, you could just pop shells on a /24. How cool is that? And you can do the same thing with Empire. So this is, I have 3 to 4 minutes. So really quickly, this is, if you're familiar, if you've ever used this tool in the past, this is just the bog standard functionality that it comes with. The new feature that I will be releasing after this talk is module chaining. So really quickly, this allows you to chain, as the name implies, multiple modules together. And we can do crazy stuff using this technique, like using app locker bypasses. So if you're familiar with Subt, I don't know if he's in the audience or not, but if you are, I owe you a drink. But he's come out with a gazillion app locker bypasses, and you should definitely follow him on Twitter. And I've implemented a lot of his bypasses in CME. So with the new flag, -MC, we can actually chain modules together using a specific syntax that I will be documenting after this. Yes, it will be after this. So there's another module in CME called ComExec, and what this does is it uses a com scriptlet to bypass app blocker. And you can run commands using this method on a Windows 10 machine using app blocker. So I'm going to use this bypass to execute Mimikatz. So the syntax, I would show you the slides, but as you previously saw, that's probably not a good idea. So it's this is the best way I could figure out how to implement this. I'm totally open to suggestions, so if anyone else has a better way of doing this, please let me know. But currently, what you do is you specify the module name, and if you to indicate that you want to chain the module, you just do a little ASCII arrow representation, so the equals greater than sign, and then you specify the second module that you want to chain into. So we're going to be executing an app locker bypass, which will then execute Mimikatz on the host. And yes, you are absolutely correct. I'm glad you're all paying attention. So we have now 4 callbacks because, again, this chained the modules together. So you can see we have already credentials getting in. So the first callback that we have is the .sct file, which is the com scriptlet that actually executes Mimikatz. Then we actually get a callback for the invoke Mimikatz script. So we successfully bypassed app locker, and we've executed Mimikatz on the host. And currently, this system only so in theory, this should work just indefinite with a complete undefined amount of modules. So if I wanted to, for example, from this app locker bypass, chain into another module that supports chaining, so run DLL32 exec and Mimikatz, I could do that as well. Currently, for a reason unknown to me yet, there's a bug which only allows you to chain 2 modules together. But I'll be working on that, and the idea is that you'll be able to chain an infinite number of modules together, so that you can really quickly and easily automate these bypasses and post-exploitation techniques. There's also, for example, a fileless UAC bypass, which was released, I think, a month ago at this point, using the Event Viewer program, which is standard in CME, and I don't think I'll be able to show you that just because I'm already over. But that is the new feature that I will be releasing after this talk, and hopefully you all see the value of this, that you'll be able to quickly and automatically utilize all of these bypasses and all of these techniques, UAC bypasses, to execute payloads on the host, and saving a lot of time. Appreciate that. If you have any questions, please let me know, but we are out of time. So thank you for coming. Sorry? So yeah.